It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farmers Union Iced Coffee.
Hi guys, this video today is just going to be an introduction to organic chemistry. I'm just going to try and cover some of the basics, give you a bit of an overview of organic chemistry in a nutshell, and try and just give you a basic firm foundation for heading into starting to name organic molecules and understanding some of the different reactions that they can undergo. So organic chemistry, when we're talking about organic chemistry, the word organic means there's no metals present. So when we're looking at organic molecules, primarily what we're focusing on is carbon. That's the real basis, the building block. Okay. We then have hydrogens, oxygens, nitrogens. They're really the main things that occur within organic molecules. And the real key to being able to understand, to draw and name organic molecules when you're going through this, is to understand that every carbon must have 4 bonds attached to it. Now sometimes that might be a double bond, sometimes it might be a triple bond, but every carbon has 4 lines coming off of it, okay? And that's really, really key. Now, first thing I want to talk about is what's called a homologous series. Okay? Now, the word homologous, the word homo means one. Alright, so a homologous series is a group of molecules that have the same sort of characteristics and properties. And now this comes down to the fact that they have what we call the same functional group. Now, a functional group is what we call a reactive site in a molecule. Okay, so what we mean by a reactive site is somewhere where we can make a reaction occur. Organic molecules tend to be unreactive normally. They tend to be quite non-polar, okay? They're generally made up of just carbon and hydrogen together, okay? They are non-polar when we get the molecules together, and you'll see some when we go through and do some of the drawing in the later videos, okay? And so they don't tend to react. Alkanes in particular, what they tend to do is burn, they combust, and they're a very good source of energy, and hence they're used as a fuel. But apart from that, they don't really do much, okay? So when you introduce a functional group, which is a reactive site, that's where you can start to get some reactions occurring within organic molecules. And there's a whole bunch of different reactive sites. So some of the ones that we'll be looking at in year 12, we're going to be looking at alkenes, alkynes, we're going to be looking at alcohols, carboxylic acids, ketones, aldehydes, amines and amines, okay? And so there'll be a little video on each of those, just going through how you name them, how you draw them, okay? And encourage you to take your time and practice going through each of those so you know exactly the difference between each of the functional groups. One of the keys though for organic chemistry is being able to understand the, or be able to memorize I should say, the naming for some of the different carbon atoms, okay? Now, in year 12 chemistry, you need to be able to name up to 8, okay? So you'll see a table that's flashing up here, all right? This table shows you the naming, what we use for the first 8 carbon atoms. So methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl and octyl, all right? So those what we call prefixes, the meth, eth, prop, that's what we put at the start. And so what we do is we use those to be able to name our organic molecules. And I'm just going to show you that and go through some of the steps on how we actually name organic molecules. Okay, so when you're looking to be able to name a organic molecule, these are the steps and the processes that you're going to go through. So first of all, you want to find the longest carbon chain. All right, then you want to identify any functional groups present. So it's probably useful when you're doing this to have a little sheet, which I'll show here now, which gives you the identity of each of the different functional groups. Okay, you can find that off of my website, or you can obviously find it off of Google or things like that. You can find different versions, which will just help you with identifying and remembering the functional groups. Then you identify what we call any side chains, and I'll show you what side chains mean in a minute. And then you identify the number of carbon atoms, you number the carbon atoms, starting with the end closest to the main functional group. So all I'm going to do in this video is just do one molecule, okay, because I'm going to do specific naming and drawing videos for each of the functional groups. But for this one, I'm just going to show you one and how we put those 4 together, okay? So I'm going to draw up a molecule here. Now you've got to remember that organic molecules, the backbone of an organic molecule is carbon atoms. Okay, so I'm going to put 5 down this way. I'm going to have a carbon atom coming over this way, okay? And I'm going to put a I'm just going to put an OH group on this one as well, and I'll do more of those later on when we look at different functional groups, but I'm just going to put that in for the moment. Now you've got to remember one of the things I said, the key thing to remember is that every carbon must have 4 bonds on it, okay? So when you're drawing out carbon atoms, it's always easy to make sure you put in the bonds so that every carbon has 4 bonds coming around it, okay? And in this case, all the leftover bonds are going to be bonded to hydrogen atoms. So you can see how the majority of a molecule in organic chemistry is made up of hydrogen, carbon and oxygen. And this is what we call an expanded structural formula. Sometimes you might see things written like this, which is what we call a condensed structure. So I'll show you both of them within this one video. So that CH3 is the same as having this bit here with a carbon and 3 hydrogens in there as well, okay? Now, if we're following through the steps that we've got here for naming our organic molecules, okay, we find the longest carbon chain. We can have a look. We can either go 1, 2, 3, 4, 5. We go 1, 2, 3. We could go 1, 2, 3, 4, 5 as well. So 5 is our longest chain, okay? So when you're putting your name together, if you go back to that table I showed earlier in the video, the prefix for 5 is pent, okay? So I'm just going to put the pent in there, and that's going to form the basis for our name, okay? Now, what we have a look at then is identifying any functional groups. Well, this functional group we've got up here, OH, that's an alcohol group, okay? And so there'll be other videos on these as well, so if you don't know these ones just yet, don't stress about it. But an alcohol group, if that's the only functional group in your molecule, that's going to make the naming of your molecule end in OL, okay? So this alcohol group, we're going to end in OL because it's an alcohol, so that's going to come at the end, okay? Then we identify any side chains. Well, remember what we said was our longest carbon chain is this one that goes across here, okay, those 5. So this carbon isn't part of our main carbon chain, so what we call is that makes it a side chain, if I use the right pen. So this is our side chain, okay? Now what we do is we number our carbon atoms starting closest to the main functional group. So we said now that the alcohol was the one that's going to be influencing our name based on that table we were looking at. So we're going to be numbering our carbon atoms starting at the end closest to the alcohol. So this is going to be the first carbon, second carbon, third, fourth and the 5th carbon right there. So now we've gone through and done those steps, we can bring all of this together to make our name. So what I'm going to do is I'm just going to give myself a little bit more room here to be able to write it out, and my blue seems to be working a bit better, so I'm going to go with that colour. Okay, so 5 carbon atoms in the chain makes it pent. Alright, so instead of pentane it's going to be pentanol, but it's important to identify where the alcohol group is. So this is pentan 2-ol. So that's telling us that we have an alcohol group, an OH, here on the second carbon. We also have a side chain here, which has 1 carbon in it. Now, if you remember from the table, 1 carbon is a meth, okay? So on the 4th carbon, we have a methyl group, which is 1 carbon long. So how we would name this molecule is 4-methyl pentan 2-ol. And we've done that just by following through our steps of identifying the longest carbon chain of 5 carbons, which makes it pent, okay? We've identified a functional group up here, which is an alcohol, OH. So that makes it OL. Alright, that OH group was on the 2nd carbon. Alright, so that makes it pentan 2-ol. And then we had a side chain here, which wasn't part of our longest carbon chain. It was 1 carbon atom long, so that makes it a methyl group. And it was on the 4th carbon, so it's 4-methyl pentan 2-ol. So that might be the first time you've seen a naming of an organic molecule. If it is, don't stress. What I suggest you do is you start working through each of the videos for the naming of the molecules. As I said, this is just supposed to be a bit of an introduction to organic chemistry, giving you the basics of how to go through the rules that you use for going through and naming each of your molecules. All right? So I suggest that this might be a really good starting point for you. And finally, there's just 2 other things you should be aware of when we're going through and naming, which will come out when you see some of the videos as well. And that's what you do if you have 2 of the same thing. So you just saw in that example there where we had a side chain of a methyl group. Well, what happens if you have 2 methyl group side chains or 3 methyl group side chains? Okay. Well, what we use is we use a prefix for in front of that. So a prefix is just something that goes in front of them. Okay? So if you have 2 of the same groups, you're going to put di in front of it. If you've got 3, you're going to put tri in front of it. So it could be dimethyl or trimethyl. Very rare that you have 4, but it would be tetramethyl. Okay? And then what you would do is you would use a number to identify which carbon atoms those are going on. So if we had 3 methyl groups, okay, if we would write it something like this, 2, 2, 3, trimethyl. And what that indicates to us is that there are 3 methyl groups, and whereabouts in the chain they are on the second, and the 3rd carbon atom. So the 2nd carbon atom has 2 methyl side branches on it, and the 3rd one has 1 methyl side branch on it. So we use those to in our naming as well. And then the final thing is what happens if you have a lot of side branches which aren't the same. So what if we've got a methyl group in there, we've got a bromine group in there, and we've got a chlorine group in there. Okay, so your side chains or your branches, it's a really easy rule. Thankfully they follow something which is pretty logical. Go alphabetically. Okay, so bromo would be first, that would come before chloro, that would come before ethyl, that would come before methyl. Okay, and they're kind of the side chains you normally have, but you name them alphabetically. It makes it a lot more simple. So it'd be like 3 bromo, 2 dimethyl hexane or whatever it is. Okay, so it's a really good to be able to remember these. Really good thing to be able to remember to use these 2 extra rules when you're going through and naming them. All right, hopefully this has helped you out. Encourage you to start diving into the other videos, get some examples, Google some examples, whatever you want to do. Start going through, try to name them and draw them, and hopefully you'll have lots of fun. All right, thanks guys.